So hey there fellow YouTubers, Frank Bush here again. In this video I plan on building out a monster-sized USB battery bank. You know, I've used lots of battery banks when I've been out in the field in the past. You know, most of them are around, 10 amps or 20 amps, 10,000 milliamps, 20,000 milliamps, that kind of thing. And really just to give me lighting and to kind of charge the GoPro and that type of stuff. But I get sick of those batteries not lasting long and not having enough capacity to them and stuff when I'm really wanting to draw off them heavy. So in this video today, I plan on taking all the different components you see here. This is just a plastic ammo can, and I've got all these components here that I plan on installing into that to make really a uber powerful USB battery bank that I can use out in the field that's pretty well waterproof and all that kind of happiness, yeah? And so what I'll do is I'll walk through the different components here and what they are and kind of what they're going to do in the build, and then we'll get on with it, yeah? Okay, so the very first thing I'll talk about is the box that everything's going to be going into. So this is a field box by Plano, and it's got a size of 11.625 inches by 5.125 inches by 7.125 inches, or for centimeters, it's 29.52 centimeters by 13.01 centimeters by 18.09 centimeters. So, you know, this is kind of a standard water-resistant O-ring seal, field box for holding ammo and that kind of thing. It holds between 6 to 8 boxes of ammunition. Generally speaking, these are cheap units. You can get them off eBay and that kind of thing. And, 20, 30 bucks. They're not really expensive units. And, readily available, that kind of stuff. So they've got just kind of a little clip on the side where you can unlock it, open things up, and I'll put all the components to the inside. And like I say, there's kind of a rubber O-ring seal that sits in to kind of waterproof everything and seal it up. And then if I wanted to, they have a little spot on the side of the box here where I could padlock that and lock it down if I didn't want anybody getting to the inside. I don't plan on doing that. I might just put a zap strap or something on there, but, just to keep it locked. But generally speaking, I'd want to be able to access this if anything breaks or if there's any issues with any of the components. So the thinking really is in this build, I want to keep it super simple. I don't want to do a lot of hard setting things into the box. I want to have it where any given component that I put into this box, I will have to turn around and drill a few holes in it on the side and stuff to get the things that I want sticking out to stick out and that kind of stuff, if you will. But generally speaking, when it comes to the inside of this box, I want to modify the components, which I'll mention here in a minute. I want to modify those components as little as possible and have it be that potentially they're reusable for other projects if I want in the future, or if I want to pop one out and just replace it because something's gone faulty and that kind of thing with minimal effort. So nothing in this build is going to be, really hard set in where it's not easily removable down the road, yeah? But either way, I'll kind of shift camera angles now, kind of move the other components in, start talking about those. I just thought I'd, there's people out there when they watch these videos, they want the full details of exactly what it is that I'm using and those types of things. Some people are picky about that and some aren't. But hopefully that gives you, I know the camera detail is not really the crispest, but hopefully that gives you a good breakdown of exactly what the box is. So like I say, I'll shift camera angles and then I'll walk through the other components and what I have here, yeah? Okay, so I'm going to walk through some of these components and just kind of what I'll be working with, yeah? So in the first item here, this is just a dual USB 3.0 extension with a auxiliary flush mount car extension. It's they use it in like automotive where it's a flush mount that gives USB, and on the other end, so I've got two sets of them. Here, I'll just kind of, so like I say, both are identical. I'll just set the one aside. And all it really is just get some USB plug-ins on the one side, and then it comes out to a flush mount, which has the dual USB. And like I say, they're both at the 3.0, so it'll allow kind of a higher power flow through them. In this build, what I'm targeting is to have 4 USBs coming off the box and have them all be USB 3.0, so they're all going to be able to do rapid charging and that kind of thing, yeah? So needless to say, that's kind of the first set of cables, and like I say, I got 2 of those, so I'll be doing 4 USB plugs that'll be facing on the box altogether to begin with. And then when it comes to this next little unit here, this will be for if I want to plug in USB-C to charge up the battery later on in time. And really it's just, hopefully the camera's getting that all right. It's just a USB-C input, and it's got the flush mount as well, because all these things will flush mount to the box where, you know, all the electrical components and stuff will sit to the inside, and you'll just be able to plug your devices in on the outside of the box, yeah? And it comes off to a USB-C as well. So really simple units. And like I say, that'll be part of the build. I'll walk through some of this other stuff here. So this is a buck converter. I've talked about these in the past. Really what they do is when it comes to 12 volts, when it comes to DC power, it allows you to step down. So here I've got an input at 12 volt coming in, and you know, you got your positive, negative, but then it can output, and I'll try to get that good and up close on the camera. You can see it's got an output of 3.7 volts at 10 amps. And so that's really the thinking, is this unit can actually handle, even though it's 12 volt in, it can handle a range from about 9 volts all the way up to about 30 volts with this specific model. So it's going to be ideal for me when I go to hook on solar panels. And then what I'll do is, I'll just set this down now, so you know that that's the buck converter, if you will. And then the thinking really will be, I've got these MC4 connections, and I've mentioned them in lots of previous videos. They're kind of standard when it comes to solar panel stuff. But in essence, what'll end up happening is the MC4s will connect onto the 12 volts coming in, and really it'll be supplying anywhere from 18 to 20 volts or so. But this buck converter can handle the kind of fluctuation in voltage and that kind of thing, yeah? And it'll automatically step it down to the voltage that I want to be doing everything at. So that's really ideal. I plan on hooking up a 50 watt solar panel to this at max, and this will produce 37 watts worth of power, you know, at maximum. But I find with, you know, if I plug in a 50 watt panel, you're never going to get a full 50 watts. Well, I shouldn't say never, but generally speaking, you're never going to get full 50 watts out of a 50 watt solar panel. That's just not how it is. There's losses in the system. But I'm of the belief that in full direct sun, I should be able to get about 37 watts, which should fully power this thing, yeah? So in order to charge up my lithium iron phosphate battery. Now, I've shown this in previous videos, and I'll probably add in the scene where I did the build out of the batteryless USB system in the past. And if you haven't seen that and you're interested in that, where I don't use any batteries at all, or the batteries are optional, go back and watch that previous video. I'll show a picture of it in a moment here. But needless to say, I'm using the lithium iron phosphate batteries that I used in that example. And these are really, I've got 4 different batteries here. Each of them are 25 ampere hour batteries, and they're running at 3.2 volts. I've got them all connected by aluminum bars in the front here. I've got them all connected where they're in parallel to each other. So this battery in essence gives me 3.2 volts at 100 amps. So that works out to, you know, 320 watts worth of storage capacity, which is massive for a battery bank when it comes to USB stuff and that type of thing. And the life cycle of these will last about 4,000 cycles. So I should be able to use this for, you know, the next 15, 20 years realistically with, you know, not super heavy use, but, you know, regular use on a regular basis without any issue, yeah? So then here is one of my other little things that I have. This is just some single-walled heat shrink tubing, and it's going to be used to kind of just protect some of the circuits so that they're not making contact with the battery or not making contact with each other and stuff. Given that this build's going to be relatively simple, I just want to protect some of these circuits as such, and these here, and you know, make sure that they're not, there's no risk of kind of shorts or anything else. And I just find that using the shrink wrap tubing will be an easy way for me to kind of protect some of these things. And then all I've got here is a stack of ring terminals that I'll be using. I'm going to be using, I think it's 14 gauge wire that I have there, if I do remember correctly. But I'm just going to be using some speaker wire. I got a whole bunch of speaker wire for cheap. So needless to say, it was the gauge that's capable of handling the amps and everything else that I needed. But so this is just a pack of terminals so I can hook all these different components up to the battery. And then I'll shift camera angles here and I'll kind of go in and do a close-up on these, and I'll talk about what the actual electrical components are specifically, yeah? Okay, so really there's 3 different components that I have here. There's actually 4 of one type of component, but there's 3 different types, if you will, yeah? But I'll kind of walk through each one and kind of describe what it is and what it'll be doing. So this right here, try to get that up close on the camera. This little unit takes a USB-C input, and really this is a battery charger module, charging board, if you will. So the thinking really is, on this side, there's a positive and a negative that'll go off and go to the battery. And you plug in a USB-C, and this little set of circuits here on there will make sure that it's all the proper voltage and doesn't do, overcharging and doesn't do overcurrent and all that kind of happiness. So it looks after all the logic, if you will, to keep it simple. If you want to go research these things, you can. But in essence, it keeps all the voltage and amps and everything else so that, it doesn't do damage to the battery as you're doing charging, right? Because you've got the voltage coming in off the USB-C is going to be, 5 volts, say, input, potentially higher. And then the voltage coming off here is going to be regulated out to the 3.2 to charge into the battery. And this runs at a 3 amp max. So it would take me a long time to fill this battery up from dead to full. You're talking, over, because there's 100 amps that exist in here, and this is only going, at 3 amps a shot. It would take me a good 33 hours if this thing was totally dead. But that's an unlikely scenario in my world because I don't normally let my batteries just run to death. But needless to say, that's what this little unit is here. Yeah, it's pretty simple, elementary, fairly straightforward. Now, this little unit here, this is what they call 1S 12 amp LIFEPO4, because that's the type of battery I have, the chemistry of the battery. 3.2 volt battery management system. So in essence, a BMS. So in essence, what this allows, I'll try to get this good on camera. So what this allows is you've got power that comes in here, and it comes in at 3.7 volts. Hopefully you can see that where it says here, let me flip it this way, where it says, power negative, power positive, P minus, P plus, that kind of thing. And then the outside, so that's off these 2 little pads here, and then the outsides are what runs off to the battery. And that's, battery positive, battery negative, that kind of thing, yeah? So fairly elementary units. There's not much to them, really. And but really, this will be used to do the same kind of job that the little USB-C component was doing, where it really is just protecting the battery and making sure there's no over voltage or over current, any of that kind of stuff going on as it goes to charge the battery. It'll automatically just kind of shut down the inflow of power to make sure that no damage is done. And the primary reason why I'm using this is the fact that when I'm coming off of this DC buck converter, this thing will have the capacity, or the capability, sorry, this thing will have the capability to be able to fill up this battery at about 10 hours from dead to full. Because you're running at 10 amps a go, and it's a 100 amp battery, if you will. So in a full day's, sunshine, I could fill this battery up from dead to full. And I just want to make sure that I'm not going to cause any damage from the solar charging unit, which will be the main way that I kind of charge up these batteries. This just protects the battery, make sure no damage is done and that kind of stuff, yeah? So a fairly simple unit, couple soldering points, and you're off to the races. Now, when it comes to these units here, now these are really going to be USB out for me. So I've got, like I say, 4 of them, and they're all quick charge 3.0, 2.0 FCP fast quick charge. So, it's USB charger, if you will. It's got the circuitry built into these now. I won't have to run these through this board. This board, just so you know, the battery management system board, it can handle power flowing into it and power out, and it'll limit it to 12 amps max, and that's, for my purposes, that's going to be for power flowing into the battery. But with these, they have low voltage disconnect, so it'll sense when the battery gets too low, and rather than drain the battery to absolute dead, it'll just shut themselves down. So they've kind of got that type of safety feature built into them, and that, there's that type of stuff. You can go, like I say, research all the fine details on these. but this is more just to kind of give you a surface level of what these things are going to be able to offer. And so when it comes to these 5-volt USB outputs, I believe, if I remember correctly, they had a maximum output each of 4 amps. You know, so that's fairly substantial when it comes to USB stuff. It allows for the rapid, you know, charging of devices and that kind of stuff, yeah? But my thinking really is they're all going to be wired up independently to the battery. And really, there's a positive and a negative and a positive and negative, that kind of thing that comes off of the board. It's, you know, this is the negative, positive, da da da, and I'm just gonna have wires that run off and they'll connect onto the battery directly, and I don't need any type of other fuses or any of that stuff. They'll simply sit, you know, like this kind of thing on the battery, where they'll feed in and they'll all just draw their power directly from the battery. And they've got the circuitry built into them where if it looks like it's putting too much load on the battery and the battery can't handle it and stuff, it can sense all that kind of stuff and in essence protect your battery with it as well, right? So that'll be mainly solar going in, all USB going out, and then potentially USB-C if I'm at home and I want to plug in, you know, to the wall and charge it that way rather than use solar panels. I'll have that option too. So that covers the basic kind of electric circuitry. It's fairly elementary. Like I say, there's not much to these things. Each one of these items, you know, to give you an idea, these things are relatively inexpensive. Like, I got 4 of them, but they were, what, $3.50, I think it was, each, you know? So for 12-15 bucks, you know, you're getting one of these. When it came to this little USB charge module, I paid 99 cents for that. You know, I think the shipping was more than the actual unit itself. The unit was $1 and the shipping was $3. It's one of the, you know, kind of silly scenarios. And then when it comes to the battery management system, this little component here, that was $1.68, and then the shipping. So, you know, you're not talking about break the bank cost for the electrical components and that type of stuff. They really are cheap, inexpensive units that are readily available and easy to replace. And like I say, I've got the shrink tubing. So once I do my wiring and stuff, given that there's kind of these circuit boards and stuff that sit on them, in order to just ensure that they're not making contact or anything with the metal battery, I plan on kind of just having those all sliding into shrink wrap, and after the wiring's been attached, and kind of sealing them in there, if you will, so that I'm not going to run the risk of making contact with anything and, you know, shorting any of that business or any of that, you know, stuff going on. So that's what I'll use to kind of protect things. But like I say, this will be a really simple build in the regards of, I want to have it where all of this stuff, if I want to take it apart and replace it and all that kind of stuff, it'll be a 2-3 minute job, yeah? But needless to say, I'll stop rambling about all the individual components and that kind of stuff. As you can see, it's not really a huge pile of different things, and I'll just get on with the build now. Okay, well, one of the first order of business that I'm going to need to do here is I'm going to end up having to figure out where I'm going to put the holes in this box. So, and I've already kind of thought about that, you know, before I started recording, obviously. But now I've got this USB outputs that I plan on installing on the box, yeah? And I'm going to have 2 sets of those. So there's the little screw part that kind of locks things down, so the flush mount will be, you know, locked to the face of the box. And I showed this in a previous video where I'm just going to pop that off, and I'm going to take this, and it's going to get laid here to give me, you know, I'll figure out the exact positioning. And then the thinking really is going to be, I'm going to end up using a bit of nail polish. I'll grab that, it's over in the other room. But what I can see already right from, you know, the get-go is I've got this little rib of plastic that sits on here that's kind of going to get in the way of things, because I'm going to have 2 of these sitting, you know, one above the other and that kind of thing, right? So what I'm going to do is just take my, you know, little knife here, and nothing special about this. I'm just going to go and carve off this little plastic rib that sits on there. So I won't bother showing that on camera, but I just wanted to give you an idea of what the first step will be. So needless to say, I want to just kind of clear off this plastic nub, make it a nice flush area where I can then determine where exactly I'm going to put my holes for the USB outputs to be sitting, yeah? Well, we've reached the point of the first miracle in the video. As you can see, I didn't cut myself when I was doing this. But needless to say, I took off the little plastic piece that was here and just kind of leveled it down, and that way I can set my components on there, yeah? So, and then like I say, when it comes to the USB stuff, you know, these little components are I'm gonna have one sitting above the other on the box. So this is just, you know, the back screws, if you will, for them, but it gives me perfect sizing and stuff. Now, one of the things I want to be mindful of I want to be in a little bit from this edge here, but in essence, I'm gonna set them probably in around, say, here, and give enough room for both of them, if you will, with a little bit of space, you know, something along that lines, right? I'll look to the inside of the box and make sure that I'm kind of away from the wall a bit, but then the thinking will be, I'm going to, on the inside of these circles, I'm just going to apply a bit of nail polish so I can get the spacing of exactly where things should be, and then let that dry. I showed that in the previous video as kind of my little shortcut way of doing things. So like I say, I'm just going to double check that these spacings are good, and then I'll apply the nail polish to kind of give me my drill markings of where I'm going to have to drill the holes, yeah? Okay, so it looks like there's not going to be any problems when it comes to, you know, the inside wall and all that kind of business. So just kind of hold that steady. Now, like I say, I'm just going to kind of paint in along the inside edge just to give me a bit of idea of where that hole is going to be set, yeah? So then I'll just dip again. 2 seconds. Make sure I get a half decent amount of paint on there. Now I'm just going to move that up a little bit. That looks like a good spot there. Do the same kind of thing again, where just want to kind of get bearing to exactly where that's going to sit when I go to drill the holes. Now the thinking really is, let me just pop both those off. Yeah, that one didn't sit quite as nicely as it should have. So let's just put that back on there. Make sure I'm right over that spot. Like I say, this is all just kind of really to give me guide marks so I know where I'm going to be drilling my holes. And none of this is exact science stuff. It's all, if you watch previous videos of mine, you know I'm just kind of a fumble through it kind of guy. But I worry more about, you know, how much power I'm outputting, and as long as the electrical's safe and stuff, I'm not overly concerned beyond that point. But let's just pop those back off and see. Yeah, within reason, those will be okay. So what I'll do now is I'll just let that dry for a few minutes, just so I kind of, you know, have good spots. What I'll end up doing is popping a little pilot hole right in the center of those spots, and then I'll use my step drill bit to pop out those holes, and we should have a place where we can start to install these USB components, yeah? So let me just give this 5 minutes to dry, that kind of thing, and I'll cut back. Okay, well, I just switched over to the floor to keep the mess to a dull roar. But the thinking really is I'm going to turn around and just drill a couple pilot holes in these now, where, you know, take my time, figure out where I think center is. Looks like it's about there. Nothing complex here. Looks about right. Now I'll just pop that off. Now I've got these step drills, step drill bit, if you will. And these are really just fantastic for being able to drill holes in plastic and that kind of thing, yeah. So I'll just slap that bit on there. Nope. Hold on. Bear with me. Alright, so as you can see, they're kind of tier stepped, and the thinking really is, I'm just going to set that right on the pilot holes, and this is going to be super gentle, right? I don't want to put any tension on this really at all. I want the drill bit to do the work. You can see it makes a bit of a mess for sure. Kind of clear that off. And I don't want to make a hole that's too big. I want it to fit nice and comfortable, right? So as I get closer, kind of keeping a keen eye on it. Okay, now it looks like I'm close, so I'm just gonna take my input and just give it a shot and see. I still think I'm shy with it, but that's okay. It's worth. And see, that can go in snug. So I'm good at this point in time. I'll pop that back out. I'll do the same kind of thing with the other hole and just get it prepped so that both the holes are ready to go with the USB outputs being able to mount flush against the box, yeah? So, and as you can see, the second hole is set in. It'll be a pretty snug fit. I've kind of checked it, you know, within reason. Now, all I'm going to do is throw in a little Dremel, like sander bit. And that's really just, see if I can get this on the camera. There's kind of a little bit of loose plastic and stuff that'll just kind of catch and fray there. So needless to say, I'm just going to kind of sand that off and clean up the hole, and that way there's no kind of rough bits on the outside. I know this visually isn't going to look perfect, but there's going to be the other USB-C plug that'll probably go right here, so it'll kind of hide where we cut off the better part of that little extra rib in the beginning, yeah? But either way, I'll just shift over here now. See, yeah, there's still that little bit. And none of this is really critical. Yeah, there's still a bit in there. There we go. That came off good. And either way, I know I get picky about this stuff, but it's not critical because this is all just going to be the joining that sits. In fact, I'll probably just go grab the little X-Acto knife. No, I got it. There we go. Now, it'll be a nice snug fit, but either way, I'll turn around and just install the two output flush mounts now for where they're going to go in this location, yeah? All right, well, let's try to get these in and see how they look. So, we'll just pop the first one in. Pull the cables through. And we'll pop that in as such. And we'll end up having to, I might leave those to the side. I kind of like that actually, because I don't want to have one interfering with the other where we're going to have a stack of them, yeah? So, put in the second one, feed its lines through. Like I say, really elementary. There's not much to this. Now with that one, kind of line them up. I'll obviously fine tune the exact kind of, but there we go. Something along that lines. So let's see if I catch this on the camera okay. So something along that lines, where we're gonna have the stack of the USB outputs that'll kind of sit clean like that, and you can just cap them over to keep them waterproof and all that kind of happiness, right? So I'll just turn around and on the inside now, and just pop open the box so you guys can hopefully, you know, trying to work with the camera angles as best I can to make this as clear as possible, but I know things get washy. So, but needless to say, I'll slide the little ring on and slide that up the line. And it's really elementary. So in order to kind of lock and brace that down, the little screw piece, like I say, hopefully the camera's getting that okay, but the little screw piece just turns around and screws down on there. And put that on super tight. Just make sure it's not going anywhere, you know, all that happiness. And I'll do the same with the other one, and then I'll cut back, yeah? Okay, so it's really simple. Like I say, just screw down the threading. That way it locked on, yeah? And fairly elementary, not much to it. And you can see it's starting to kind of come together from the outside, where we're gonna have the 4 USBs that are input there. We'll just kind of cover those over to keep everything clean. And like I say, if I had to, I could just loosen it and tweak this and adjust the layouts. That's all easy enough. But now the same thinking is going to happen with the USB-C inputs, where I'm just going to turn around and unscrew that threading there. 2 seconds. Really should do more prep work off camera, but such is life. So, and I'm going to have the exact same kind of thing happening where now I can determine where I'm going to have my USB-C that's going to be feeding in. Then I'll quickly just go and grab my nail polish. 2 seconds. Where did I put that? I always move stuff and then forget where I put it, right? Classic Frank moves. But needless to say, we'll do the exact same kind of thing where, okay, I'm going to... And I want to kind of cover over that ugliness that's there a bit and make sure that everything's going to be kind of out of the way. So maybe I'll do it somewhere in around that location. And it looks like it'll still give me enough room to screw everything down and da-da-da, but also kind of get rid of where I cut off the stuff. And it's really all kind of free, you know, put it wherever you feel like it's going to work kind of thing, right? That's where it's a bit of fun in that regard of... You can kind of lay these things out however you want to. Be good if I got more on the box than on my hands, but such is life. That tells me roughly where this thing is going to go. And you can say I'll give that a few minutes to... Yeah, I've made an absolute mess of it. But I'll go wipe off the nail polish that I've done on there and just kind of let that dry enough. But I'll go off the bottom. It looks like the bottom part of the circle was a little cleaner. And kind of clean that up a bit. Like I say, I made a bit of a mess on this one. But either way, I'll let that dry for 5 and we'll do the same kind of thing, right? Okay, well, this is where the camera work starts to get a little dicey, but either way. So, as you can see, the USB just kind of has this little mount, and then there's a cap that I can turn around and just screw on to the face of that. And that's really just to kind of seal it down. And like I say, this will be for power input. And then here's on the inside, you can see mounts nice and flush to the box and all that kind of happiness. So I'll see that is connected now. And now the only other 2 holes that we're going to need to set in, which I'm probably going to do below where this latch is, because the latch itself kind of sticks out of the box a bit, but the MC4 connectors are going to stick out of the box a bit as well. And I want to use this latch intentionally where it kind of sits out when it's closed. Here, let me just throw the wires in and kind of show you exactly what I'm talking about here. So I'm going to just press those into there for a second. But when the box is closed and latched up, like I say, I know the camera work gets shoddy in showing some of these details, but when the latch is closed and kind of, see how it sticks out from the box a bit? Well, the MC4 connectors are going to stick out as well. So down in around this area is where I'm going to end up hooking in the MC4 connections, because they stick out, you know, a good ½ inch or so, give or take. And this will just help stop them getting hit and potentially getting knocked and broken or damaged as we move through time, yeah? So either way, I'll shift camera angles and kind of gear up to get ready to do the MC4 holes. And then all the holes will be set into the box, and then we'll move into the actual wiring things up. And like I say, on that side of things, it is fairly straightforward and elementary, so things should start to move along fairly quickly as we go through the video from this point in, yeah? It's really just getting all the holes set in and stuff to begin with, take a bit of time. Okay, so like I say, I want the MC4 connections to be on the side where the latch is, but I don't want the latch itself to get in the way of anything, obviously. That's, you know, fairly self-evident. So needless to say, what I'm going to do is just pop off the end cap of the MC4 and use that as kind of my bearing. And I want to have it where this latch handle is never going to hit that MC4 connection. And given the layout of how I want to do things as I move forward later on in time, I'm just going to put the MC4s here. I'm just going to kind of give it a simple little dab there. And I'll move down and do the other one below it. And I'll give that a dab in about there. And really that's just going to tell me roughly where those MC4s are going to go. And I know I'm far enough away from the side here where it's not going to be a problem. So that should be good in that regard of, and I'll just double check that I'm not you know, too tight together with these. And yeah, as I can see, without issue, we should be fine. So needless to say, I'll let that nail polish dry, and we'll turn around and drill those holes out as well. And these are small as well, so you know, I'll have to use the smaller step drill bit and that kind of thing. But I'm just going to prop that up because it's sitting on a bit of an angle given the nature of how this box is shaped, and I don't want that nail polish kind of running, if you will. So either way, I'll let that just sit and dry for a minute, and then I'll come back and we'll drill those holes, and then we should be through with all the drilling of the holes. Yes. Okay, so I just pretty well did the same thing for the MC4s. I didn't bother recording all that because you guys have seen the details of those. But needless to say, got the 2 holes set in, and as you can see, within reason, it's a tight fit, but I'll have one here, and the other one will go right below it. And that gives me enough room to kind of, and like I say, the one below it's a little bit of a tighter fit, but hopefully that gives you an idea of the MC4 connections will end up connecting in. I'm not going to hook those in right at this point in time because there's still a bit of wiring and stuff I need to do to those, but at least the holes are there. So one way or the other, the box is kind of ready to go to move on to the next step of starting to get stuff into the inside of it, yeah? Okay, so I've cleaned up the holes for the MC4 connections, and that way they all fit through nicely, that kind of thing. So now what I'm just going to do is, I've got a, like I mentioned earlier in the video, I've got a huge spool of 14 gauge speaker wire that I got for really cheap. So I'll be just using this wire for this, and it's good enough for the amperage. So what I'm doing is really just going to take a bit of length, and then that way I've got some spare wire that'll be sticking out of the box that I can wire up later. And we'll probably trim this back a bit, but for right now, I just want to kind of get something together for these MC4 connections, yeah? And that way we can start to have that kind of working for us, if you will. So now, on these cables, and I want to kind of keep these cables together within reason. So on the cables, there's a white line running down the cable, and I'm going to treat that as my negative. And like I say, that runs the full length of things, so it's easy enough. But now when it comes to the MC4s, they're a little bit kind of reverse to convention because of how the connections work and stuff. And but needless to say, the positive is going to be the female MC4. So the way I'm going to work that now is I'm going to slide on my little, how am I going to work that? Let me pull these apart all together, and we'll just do it that way because it'll be easier. And this one doesn't have the white on it, so I'll just use that as my positive, and that'll be fine. Sorry, I got to think through these things as I'm going. I really should think about them beforehand, but you know, such is life, right? So needless to say, just strip off some of the sheathing, and I've got to clean up my floor. I got tons of plastic bits lying around everywhere, but that's one of the reasons why I shifted over to doing it on the laminate instead, the hardwood, if you will, instead of on the carpet, because it just helps keep the mess to a dull roar. But needless to say, I'll kind of clean these up a bit so that I'm ready to kind of wire things. And there we go, it should be good enough. Now, like I say, that's the negative wire. So now, like I say, we're going to turn around and have the positive feed into the female MC4 connection. And really, because the line's coming off of the solar panels, we'll have the positive, which is the male end, that'll plug into this. So I see that as being kind of the lead point. But now the way these MC4 connectors work, there's male and female connectors that'll end up connecting with each other. The male internal bit goes inside the female. So I'll be wanting to use that one for the female connection. And I'll just double check everything. So yeah, male and the female, that's the way it needs to be. And we'll turn around and just give that a squeeze and kind of get those on. And I know you should use proper crimpers and everything else. If the purist in me understands that, but the realist in me doesn't. So needless to say, check your connection, make sure it's on there good and solid. When you put this inside, you'll hear a click. Hopefully you heard that. That locks that in, lets me know it's kind of set in place really well, right? So I'll turn around and feed that through the hole and set in my MC4. And I'll do the same thing now like I just did for the male side. I turn around and put that there. And really, you're just kind of squeezing these on. Make sure they're on there really well. It's not going anywhere. It's on there good and snug. Now I'll click that in. There we go. So that's clicked in, ready to go. It's not going anywhere. And I'll feed that through the hole that I drilled. And pop that one on. Now I've got the caps now that'll go on the other side. Now they've got a little pointy side and a flat side. So the way it works is I'll just grab one of these wires, and turn around and put the pointy bits on facing inward. Slide that down the line. Oh, sorry. I put that on backwards because being a fool. Pointy side facing outward. Slide that down the line and let that set right into that MC4. And now on that same line, we're just going to slide down now the little screw cap piece. And that'll go down. Make sure that's screwed on there nice and tight. And I'll get my pliers in there and all that happiness. And I'll really make sure that that's cranked down really tight. And we'll do the same on the other connection where, like I say, feed the pointy end on first. Let that slide down. Oh, I'm just, why am I being such an idiot? Pointy end on, facing outward. Same mistake twice. Always when you're on camera too, right? You'll be able to tell though, because it should just lock in. The little pointy bit should face out, and it should be able to just kind of set flush in on that. And really what it is when you tighten down on these threadings, it'll squeeze on the pointy bits and clamp onto the cable, if you will. That's the thinking of what it's doing. And it just helps kind of ensure that there's solid waterproofing that's occurring there, right? So, needless to say, I'll put that one on. I'll tighten both of those down really well so that they're locked on there super solid. And then I'll shift camera angles and I'll show you what it looks like as a clean MC4 connections on the outside of the box and how much it sticks out past this edge, yeah? Okay, so I cranked those down really tight. They're locked on there. Hopefully the camera is able to see that half decent. They're in there pretty solid, yeah? And the wire's just out so I'm able to do things later on. And as you can see now, that's where I'll end up plugging my solar panels into this. And when it comes to the overhang, hopefully I'll catch that on a half decent angle. There's still about quarter inch, maybe half inch tops where it overhangs on that side. But hopefully this edge here will help kind of stop that getting banged by accident or any of that business, right? But such is life. That seemed to be the best way I could end up laying things out. But either way now, I'm at the point where the wiring's been set in where I will be able to feed the solar panels in later on as we move through time. So now the next part of the build will be, I need to grab some two-sided tape and we should drop that battery into the box now. We're getting to that point of the build, yep. Okay, so I went and grabbed the two-sided tape. So now I've got my positive line runs down this side of the battery and it's marked with a bit of nail polish on the top where the pluses are and there's negatives on that side. So there's not going to be any confusion of which side's the positive, which side's the negative, that kind of thing. But needless to say, on the bottom of the battery, because this will be faced that way, if you will, that on the bottom of the battery, And if you're wondering, I just went and bought an aluminum bar, drilled some holes in it, and strapped them together to be in parallel. If anybody was kind of curious to, how this monstrosity of a battery ended up coming together, that's generally speaking what ended up happening. But I'm just going to stick on some two-sided tape here to the bottom of the battery. And this will just help stop it from jostling around later on in time. Let's just stick a bit of that on there. Come up to about here. There we go. No, nothing perfect. Doesn't need to be. Just needs to be enough to kind of hold things on. And of course, I talk about this in previous videos, but almost every time, right before I do a video, I don't know why, but I end up clipping my nails. Just the timing of it. But I want to peel back that kind of protected bit. Just set that to the side. Now, I want to have the terminals of the battery. I want to have those down on the end by the wiring. And it's all protected and stuff in there, so it should be okay. But the thinking really is I want to kind of center place this within reason. Maybe a little bit off to the side, but I want it to be kind of dead center as I can without getting all the wires hooked into it. Bear with me. And kind of get that centered into the box as best I can. That looks like it's pretty good. We'll just kind of set that down. All right. So now the wires coming off of the USB outputs, they're just wrapping around the outside edge of the battery there, which is fine. I'm gonna tuck those in now. And like I said, I didn't want to kind of set those right in underneath those MC4 connections. And wrap those right around, because I'm going to go right around this battery to not have to snip any of these cables. And at the same point in time, it's going to kind of help keep that battery set in place. Now, all my USBs that are going to be, the plugs, if you will, I'm going to have down at this end. And I really should have thought this through a bit more, but such is life. And they're going to kind of sit in as such and have a bit of wiggle room where they can kind of move around and that kind of thing. So it'll be kind of like that now. And sorry, I keep bumping the camera a bit, but such is life when it comes to doing these things. There we go. And now, like I say, that two-sided tape will help kind of lock that down, but having the cable wrapping around the battery will do that as well. And it's all, insulated, protected wiring and all that kind of stuff. So I'm not worried about any shorts in the wire. And I didn't have to snip or cut anything. And that's kind of one of the key things that'll make it that, later on I don't have to cut anything or, unsolder anything when it comes to these things. There's a few things I need to solder in this video, but it's still fairly minor in that regard. But just kind of make sure everything's nestled in and that these USBs should be able to reach the zone, and they can. So that's excellent in that regard. And like I say, I didn't screw with the MC4 connections too badly, so they're still sticking out without issue. Everything's good in that regard. So now that the battery's in there, and I'll just confirm that, yeah, I've put the positives on this side, if you will, the side that's closest to the outputs. So just to kind of keep that in mind for later. Now, the first order of business I want to do is off that USB-C that we had put on, the input off that. I want to turn around now and let's just set that line kind of down and into the ether and out of the way. But I want to set that line now. On the end, I'm just gonna, in fact, you know what? I'll cut angles here. I'll go grab the other piece and that kind of thing, and we'll kind of walk through the next steps of what we're gonna do with this USB-C, yeah? Okay, so I just plugged in my soldering iron, start to get that going, because that'll be part of this next step. But so I had that USB-C that came off of the input where we're going to be able to charge, yeah? And what's going to end up happening here is that's going to end up plugging directly into this battery charging unit that I mentioned in detail earlier in the video. And the thinking really is you just simply plug it and click it right into it. There's nothing to it. It's pretty elementary in that regard. But before I end up kind of going off and doing that, there's a battery positive and a battery negative that exist on here with the little pads. So what I'm going to do is I'm going to solder on some wiring here. So I'll just take some of that wire, and don't need massive length of this. But just going to turn around and kind of clean that up a bit. Now I only need a small amount for the pad, and I'll do a little bigger one for the other side, just so it can hook into the terminal. Kind of clean that up a bit. So like I said, with this wire, my convention is that the one with the white line is going to be the negative, and I tend to do that, generally speaking. And do the same thing again for the positive wire. Come on now. Where I'll split off a bit for the pad to solder onto that. And give it a bit more on the other end, just so I can connect to the terminal clean. Perfect. And that soldering iron is starting to get toasty already. So that's my thinking really. Now what I'm going to do is I've got two of these little blue terminals, the ring terminals there. Might as well put one on where I left a bit of extra wire on that side. See if I can slide that in there okay. Sorry about that, just had the phone blow up, so I had to shift camera angles and that kind of thing. But needless to say, I just crimped on a terminal on the positive line. And now on the negative line, I'm going to do the same kind of thing. Simply just slide your wire into there. And then on the crimper, there's a little crimping spot where you kind of set in on there. Really elementary. And just give it a good squeeze. Make sure it's on there. I always like to kind of double do them. Make sure it's on there good and solid. Give it a tug test. Yeah, it's all good. All right. So now, like I said, that'll be for the negative. So that'll be on that side. And that will be the positive. I'll just double check. I got no white lines running down wires. And that'll be on that side. So now the thinking really is, now that my soldering iron's nice and toasty, I want to turn around and just right on the pads where the positive and negative are, I'm going to put a bit of solder onto those. Kind of pre-solder the pad, if you will. And doesn't want to go on there. All right. And now I'll turn it this way for ease of doing things. Now, like you say, really want to double check to make sure you're connecting your right connections to the right connections, if you will. But I'm going to turn around and now confirm that that's the negative, and it is. And I want that to be on that side, so I'm going to heat up that solder again. Okay, so needless to say, as you can see, wired on the 2 lines, and a bit of a mess, but such is life. I really need a better soldering iron. I know that. I really lowballed it in the beginning, but so I'll just kind of keep those 2 connectors separated. But I'm just going to plug this in to show you how this lights up, because it'll all be wrapped up in a bit. Where, turn the light on. I've just got this extra battery as a sample. So in essence, what'll end up happening here is the charge will flow through the USB-C, and that'll be coming from off the wall or whatever, right? And it'll flow through here. And now this is throwing charge out to here. And when it sees that the resistance gets high enough, it automatically kicked off because I'm not actually connected to anything. But what'll end up happening is once this is all hooked up to the battery and stuff, we'll start throwing charge. In fact, I'll just quickly wire this up to kind of show you guys, yeah? Okay, so like I said, I soldered up the USB-C. Now I've just connected it up to the positive and negative on the batteries, yeah? And I'm going to take that USB line that we originally installed in the box here. Now I'm just going to turn around and plug that into there. And won't see anything light up quite yet. But I've got this little battery bank here, which I've had shown in lots of previous videos. I'm just going to turn around and use that to be my power supply. So now on the side of the box here where we put in that USB-C input, I'm just going to connect in my USB coming off that battery bank, and that could be from, you know, any USB source, if you will. And then I'm just going to turn this on, and you can see as soon as I turn on the battery, now this battery is feeding through a USB cable. It's going through the input on the box here. It's lighting this up because that's really just doing a battery charge to the battery, yeah? So we know that the basic wiring now is kind of set up for the USB to be able to start to charge this battery, which is always a good sign. And like I said, this light would end up flicking green when it's fully loaded, yeah? But what I plan on doing is I've got that shrink wrap stuff that I'd mentioned earlier in the video. I've got some of that stuff, and in order to kind of protect where I've done these connections and all that kind of business, I'm just going to end up covering that entire thing with shrink wrap and sealing it so that it's really kind of hardwired in, and I won't be able to see this, but I know that that's what it's doing kind of in the background. I just want to have it that this isn't going to touch anything and make shorts on the metal of the battery or any of that business, yeah? So that'll be the next step. And you can see as soon as I turn around and unplug the USB-C, it drops the charge as you can see, really. And, you know, it'll be like that kind of moving forward, right? It'll automatically kick on, kick off. It'll automatically stop charging when it's, you know, reached a full battery and all that kind of happiness. So I'm not worried. It'll do all that kind of stuff behind the scenes. And like I say, the next step really is I'm just going to detach this from the battery, and we're going to put on that heat shrink. Okay, so just to recap, I'm coming off this battery just as power supply. That could be off the wall, the equivalent of, yeah? And I'm just going out through this USB Type-C extension to the input. The input's coming around. It is this cable. I'll just plug that in to make sure that the connectivity is still all happening. Turn this battery on. Yeah, we light up. I don't want to touch these 2 ends or it'll short. And you'll see this flicker green. It'll has safety into it where it sees it as like a full battery. Then it'll just kick on the green light as well, right? But I can see that's all working now without issue. And then like I say, I'm just going to turn around. I put a bit extra tape on there. I don't know if I mentioned that, but just to kind of make sure that when I'm pulling on the wires here, it's not putting extra strain on the solder points, yeah? And so needless to say, I'll just kind of slide that on over top of things. And that'll be as such, if you will. And really, I just want to cover the entire thing, so I can still plug this in and unplug it and all that happiness. And like I say, well, turn this battery back on so it lights up. It keeps wanting to turn off because it knows it's not connected to a load, right? But so I won't get to see that light anymore, which is fine though. I accept that as just part of the deal in order for me to have more of like a short circuit protection stuff. So like I say, I know that that stuff is still going on in the background. I'll just press that button again. Let's see if we can see it lighten up red on the inside there. So I know it's still all working. Everything's good in that regard. So I'm just going to unplug that though. And when it comes to this end now, I'm simply just going to take my lighter, because like I say, this is heat shrink, and kind of heat shrink right onto that whole thing. You know, and you definitely don't want to apply too much heat, but just to kind of make this all go tense, right? And then it becomes almost like one solid just cable. So I'm hooked on the thing, sorry. So let me just flip it over and kind of make sure I'm getting all the different sides and all that happiness. I really just want to apply light heat enough to get it kind of shrinking on there, right? And that'll become pretty evident as we go. As you see it just kind of pull down onto everything. All right. There. Now, as you can see, it's kind of just a sealed unit, right? I'll let that all cool down first before I go putting it in. And if I had to unplug this USB-C, I can do it right here still. If I pulled on that, it'll free off. But this really kind of keeps this entire circuit protected and stuff now, yeah? And now the thinking really is I can turn around and just stuff this into the box and put it in, you know, however I want to kind of nuzzle it in there. And really, I'm just kind of running it around the outside of the battery like I did the other cables. And it really just helps give buffer. And now when it comes to, like I say, I've got my negative is on this side. So here, let me, oh, should have done that. Let me see where we're at. So, like I say, I know that the negative is on this side. So I can look at pretty well just kind of permanently wiring this in now, within reason, and just say, okay, let's slide the negative on the negative. And I've got my screws kicking around here somewhere. They're on the floor. Yeah. Like I say, I'll end up having to take this all off again later in life. But I just want to kind of show you. It's getting late in the night for me, so I'm probably going to stop at this point and finish this video off tomorrow. And I'll still make it just one solid video kind of thing, but needless to say, for my day in my world, if you will, I'm just going to hook that onto, and I don't like how that one's just a little bit loose. It'll all get tightened up at the end, but just, sorry, I know I'm kind of catching this on camera of just reconnecting batteries, but such is life. But kind of moving forward is the rest of the steps for this. It'll be doing the same kind of just soldering and wiring up all those USBs I had showed earlier. So like I say, I'll stop here for a second. So like I say, we're kind of at the point now where, as a sealed unit, I'll just stuff those inside. Let's see, as a sealed unit, if I could close this up right now, I now have the capacity, one way or the other, to plug into here and get it to start taking a charge. And I know it's doing it, even though I no longer have the ability to see the, light up, if you will. One way or the other, the capacity of this battery is really, really deep. And if I was to use this out in the field, to give you an idea, I could use all of these USBs at full throttle, pulling 3 amps each, which, most devices won't even take that. But, with standard cabling that people use, like Lightnings and, standard USB and that kind of stuff. But needless to say, I could run that for 8 hours non-stop, all 4 of them going full bore, right? Like, when it comes to realistic use, I plug in a 3-watt light bulb or a 5-watt light bulb into this thing, and I'm able to run that thing for, what I think when I worked it out before, it was I could run a 3-watt light bulb for 5 days and 23 hours non-stop, 24/7, or like 24 hours a day, before it needed a single recharge. So either way, the depth of this battery is there. I don't have any meters telling me where it's at. I do want to get a voltmeter. I just don't have one available. And that won't be part of this video, but I'm going to end up installing a voltmeter on the top here that tells me what the voltage is of the battery itself. Then I'll get that as just a little flush mount waterproof thing. I just haven't found the proper one to kind of match to what I'm building here. But this is kind of a good point for me to call it a night, and I'll start again in the morning. But the next step will be to turn around and hook up the USB output now, because now we got some input, and to hook up the solar intake so we can come off, regular solar panels, and to hook that into the battery as well. I might do that first and then do the USB as the second thing, as all the outputs, and then it'll all light up and we'll be off to the races, if you will. So I'll stop it here and I'll cut back in the next scene. Okay, so now for the next step, I had this battery management chip here, yeah? And this is that buck converter, and the black and red that's coming in, that's going to be coming from the MC4s, which we have the wires in the box. So we'll do that later on. But at first, the output that's coming off this now, I want to connect that to the power and to the battery. So I've gone and snipped 2 additional wires, and they're going to be coming off this little BMS, and they're going to be running off to the battery. And these 2 wires right here, I'm just going to solder on to those 2 points. So I've still got to tin up those lines with kind of pre-solder things, if you will. But needless to say, I'm on the pad of the power now. I'm just going to turn around and put on a healthy amount of solder onto that pad. Just kind of let that sit. Now the thinking with soldering, I know a lot of people kind of get scared of doing soldering, and to be quite honest, I'm not great at it either, but the thinking really is you don't want to heat up the solder and kind of drip it onto, your connection. The thinking is more you want to heat up the connection, and then when it comes up to temperature, allow the solder to melt into it. So, it's kind of counterintuitive to a lot of people. They think that you kind of put them together and then just melt and drip the solder onto it. And that's not how it works, right? So let me just kind of spin this a bit. And I know, because I didn't give the best example. I went back and looked at the camera work. I didn't really give the best example on the last. So my thinking really is, and let me kind of pick this up and see if I can get a close up. So you can see I've put a good little bead of solder onto each one of those pads, yeah? On the positive and the negative. So now the thinking really is, when it comes to wanting to make my connections, what I'm going to end up doing is I'm going to heat up that solder, get it back to the point where it's kind of liquidy. And I really should have a set of helping hands here, but I just don't have any of those because I try to avoid soldering like the plague, to be quite honest. But needless to say, I want to heat that up again to the point where it kind of liquefies. And while that's all heating up, I want that wire to heat up as well, right? I want that all to become up to temperature where the wire already had a bit of tinning on it, just so you're aware, but as that solder liquefies, I want to kind of set that wire right into it then. And that's the way to kind of get a good connection, if you will. It's getting warm on my fingers, and such is life, but and I really want to just let the heat of that build to the point where that solder will reliquefy. This is where I really could use the helping hands. Helping hands are like 2 little clips with magnifying glass type thing that helps you just kind of hold on to everything as you're doing this stuff. If people are wondering kind of what that is. All right. So as you can see, as that solder kind of gets to the point of liquefaction, if you will, I want to make sure that that wire is right in good contact with it. And that way I get a nice clean connection. I'll put a little tiny bit more solder on that after the fact, but that's the thinking really, is because I want to have the lines coming clean where I can put the shrink wrap tape, if you will, that I talked about earlier. I want to be able to put that over top of this unit. So I want to have these two wires going onto this unit, but I want to have these two wires kind of running out parallel to each other and off this unit. So just the way I'm wiring things in, that'll be kind of how things are. So I won't carry on doing this. I just wanted to kind of give a bit of an example of soldering. Like I say, I'm no pro, but it's more in the reality of you want to heat up the different components and then the solder melts into them. It's not the other way around. You're not trying to heat up the solder and just melt it into a cold component. Everything has to become hot so that that solder becomes one with everything, if you will. And everything's hot enough to kind of absorb the solder at the same point in time as they join. Hopefully that makes sense. So needless to say, I'll cut it here. I'm just going to go off and solder these components together, and then we'll move on to the next step, yeah? Okay, so I got the soldering done on this now. I'll just kind of bring it up and show you up close. So, like I say, I've got the positive and the negative that's coming off of the buck converter. And that'll really be what's converting the 12 volt coming off the solar panel. Could be closer to 18, 20. But this buck converter is variable, like I mentioned earlier. And then given the way that they've laid this thing out, I've got my negative hooked in here and my positive that's connected on here that'll go off to the batteries, yeah? So these two lines will be the main ones that are actually going to be connected out to the battery. And just like I did earlier, in order to stop any kind of potential shorts or any of that business, what I want to do is just kind of put some shrink wrap over top of this entire thing now and kind of seal that all in as such. And I'll be able to use this if I decide to kind of rip this apart, this entire build, and use this for other things. Now, any type of lithium iron phosphate battery, I can connect in a regular solar panel to this if I'm running just a single 3.2 volt cell. And this BMS will be able to control the charge going into it and all that stuff where I'm not going to do any damage to the battery, yeah? So I should just kind of make sure I've got a bit of wiggle room on both sides. Should be okay. All right. So, like I say, I just want to kind of shrink this up now so that it all just kind of wraps tighter onto that unit, yeah? And you definitely don't want to let any hot spots sit on there for too long. I'll just kind of let it slowly pull itself together. I just don't want to melt any of the insulated wire that's inside it and that kind of thing, right? And want all that stuff to still be in a good situation. But as you can see, kind of cleans it up a bit. Makes it that it's just a bit more kind of stable when it's sitting inside the box, where I don't have to worry about it touching anything or any of that kind of stuff, right? And you know, you could use, if you don't have this kind of shrink wrap stuff, you can use things like nail polish to kind of protect circuits so that, you know, they're not going to short as easy and those types of things. But, you know, it's not ideal. That's more kind of the poor man's solution, if you will. But such is life, right? I mean, these shrink wrap tubes are only cheap anyways, but it's more about availability than anything. So as you can see now, it looks like kind of just a clean sealed unit. So I'll let that cool and that kind of thing. Now on this end, I'm just gonna snip off the ends, clean them up like I showed earlier in the video, and just put some terminals on that. I won't bother recording that, I'll just go off and do it. But then this component will be ready to hook onto the solar panels as the next step after that, yeah? Okay, so like I say, I just went and put those end terminals on there, the little ring terminals on the end kind of thing, right? And as you can see, I'm pretty well wired up where I'm ready to connect up to the battery for the buck converter now. And all I need to do at this point in time is the positive and the negative that's coming in on the buck converter, the red and the black, if you will. I need to connect that up to those MC4 connections that we kind of set up the wiring for earlier in the video, yeah? So I've got, let me see here. So I've got what they call butt connectors, and these are used to kind of join two separate wires together. You stuff your wires in on both sides, and then you just kind of crimp them down. Simple little components, but it allows you to kind of connect two wires, if you will, with ease. So I'm just going to take the -1 now. Let's make sure I see the one now, because we had that convention where I had the white line that's running down that cable. Lets me know which one I should be connecting to, yeah? And I want to turn around and just kind of slide that into the butt connector and get it good and in there. Now the same with the, because we're on the negative now, the same with the black that's coming off the buck converter. I want to slide that into there and make sure they're both kind of set in good and deep. And I'm going to come along with my crimping tool and just last minute double check, make sure everything's set in there really good. And start just crimping down on that connector, yeah? And I'm going to end up doing the exact same thing for the positive. And then that'll be all wired up and connected, yeah? So as you can see, nothing to it. Those wires are now connected and they're protected where it's not going to touch a short or any of that business. So I'll see that as good. I might turn around and just give it one or two more squeezes, because I always like to make sure this stuff is done really firm. Yeah. Okay, so like I say, that wire's connected. I'll do the exact same thing with the positive. I'm just going to turn around and grab another butt connector, and it'll be the same thing with this, where I just turn around and connect those. So I won't bother filming all that. I'll just wire it up, and then we'll look at hooking this up to the battery as next scene, yeah? Alright, so like I say, we've got all the butt connections connected on and all that happiness, so we're in a good state in that regard. Now we'll just kind of set the wires in. Now I'm going to just tuck this buck converter down in beside the battery, and it'll just kind of set into that zone, if you will. And then when it comes to connecting it to the terminals, just the same again now, where I want to turn around and say, okay, which of my cables has the line on it? That'd be that one. As you can see, hopefully the camera's seeing that. Just to confirm that that's my negative. So I'll pop that on my negative terminal and just screw that back on. And you can see all of this stuff, the way I'm designing it, it's all designed to be where I can pop this stuff off and replace it or use it in something else if I needed to on the fly, or, any of that kind of stuff. I want it all to be kind of, simple components that I can replace or, use in different contexts if I wanted to really easily. One of the things I like about doing builds like this, or I try to, at least anyways, within my builds, is to make it that I modify the raw components. Oh, that almost went into the ether. And I modify the raw components as little as possible. I know there's guys out there, they like to snip cables right to the exact length and da-da-da, and I'm not that way. I sit back and say, the least amount of modification I can do to anything, the better. Because then if something goes wrong and a critical component dies or something, and I just need a piece out of something, it's easy enough to just pop it out and use it. I'm not, when I'm out in the field and stuff, I might not have anything but my multi-tool, and if I want to just kind of pop things off to, use a component because something else didn't work or whatever, it gives me that level of flexibility. Hopefully you understand what I'm saying in that regard. But now at this point in time, as you can see, kind of seal the box back up again. Now at this point in time, these MC4 connectors we're not going to see any lights or anything light up, so there's nothing's going to tell me it's going to happen. I'm just going to end up testing this box and getting a feel for it as I move through time, yeah? But one way or the other, these MC4 connectors should be able to take in solar panels with, anywhere from 12 up to, I think it was 30 volt range that the buck converter in there was rated for. So, needless to say, I now have my inputs completed on the box where I can take in the USB-C or I can take in solar, yeah? So the last remaining thing will be to deal with powering up the outputs now. Okay, so now, as we're getting close to the end of the build now, so like I said, I had these USB 3 outputs, yeah? And I've got 4 different ones of these. Now they're just sitting on a breadboard that's all connected. I could snap those apart easily enough. Right along here, there's kind of lines where I can just snap it and break it. And if I wanted to have individual ones and just use a single one, it'd be easy enough to do. But I just kept it together because I wanted all 4, and that's just how they came and all that kind of happiness, yeah? But needless to say, my next step that I need to do is connect the negative and positive, negative and positive, negative, positive with wires that all run off and put terminals on them. And because I've gone through that all in the earlier part of the video, I won't bother adding that in at this point. I'll just go off and do it, yeah? But I'm just going to use that same cable I had earlier, snip some lengths of a couple inches each, and wire up. Hopefully that camera can see that okay. Wire up to, the same little pads that I was talking about earlier where I just got to put a bit of solder on them and connect the wires, yeah? So, not a major issue. And I'll go off and do that now, and then I'll cut back, and this should be fully, have all the wiring and connections already set up and ready to go for the next step, yeah? Okay, so I went off and soldered all 4 of them and got them kind of set up, if you will, where they've got their little end terminals and that kind of thing. Now, I was going to keep them all together as a set, but I found when I was soldering, some of the stuff was really close to each other when it came to the positives and the negatives, in the different outputs, if you will. And I didn't really feel comfortable with that, so I decided to kind of separate them all off and just make them independent, yeah? But really, the next step will be wiring these up to the batteries. And I'm just going to check my shrink wrap. Potentially, I'll do some wrapping up near where the connections are themselves. But yeah, it'll be hooking them up to the batteries. And then when it comes to, I'll just shift them to the side for a second. When it comes to inside the box itself now, we just got to hook onto these USB outputs. And we should be cooking with gas, if you will. This project should be pretty well there and ready to go. So, give me 2 seconds to kind of get my poop in a group on this end, and I'll cut to the next scene, yeah? Okay, so, like I said earlier in the video, I want to have this entire build be really flexible where I can just pop anything in or out. So but unfortunately, the battery's got a metal case. So what I'm going to do is just kind of slide in some plastic in here and have that kind of sit as a buffer between any of these USBs that we're going to be using and the battery case itself. Just kind of give that layer of protection, if you will, right? And this is really just to stop any incidental conductivity. And the reason why I'm doing this, there, should all be in pretty good place now. And now the reason why I did that was with these USBs, now they're going to be held by connecting down at this end. So they're simply going to turn around and, pop into their connections. And I don't have to worry about, them touching anything or any of that business. But I want to have it where if one of these pops, because like I say, they're only $3 or $4 units, right? So if one of these pops, I can easily just pop it out and replace it without having to dig into the guts of, the build itself. So what I'm going to do, though, is, like I say, the same as everything else. We've got the negative with the white lines on it, and then the positive. With all 4 of these, I'm just going to hook them up to the USB connections here and wire them into the battery, yeah? And I'm using these bolts on the battery like a bus bar for, all intents and purposes. So, normally you only do maximum up to 3 connections on a battery terminal, but with the way that I've kind of constructed this, this almost becomes like bus bars that are running, where I can make multiple connections. So, you know, for the purists out there that are electricians and watching the show and that kind of thing, I know they're going to be like, but when it comes to, you know, from my lens, this is the simplest and most compact way that I can get kind of like a bus bar running without having to go into a separate like fuse block or something like that, just to save on the real estate on the inside. Yeah. So, but needless to say, that's what I'm going to end up doing, is hooking these 4 up, setting them up to the batteries, and then we'll start to plug in to the USB outputs and see if we're getting power through these devices. Yeah. Okay guys, so I just did a kind of quick wire up to begin with. I need to shrink wrap these to stop them from touching each other and getting any type of shorts or any of that business, yeah? But that's a minor issue. I'll run up to the hardware store and grab some more larger shrink wrap, and that way I can get around these things. But needless to say, I thought I'd just kind of stop at this point in time, now that we've got the basic wiring up and running, then start plugging stuff in. So what I'll do is kind of just slide the camera back a bit. I just brought over a jumbled mess of lights that I have that are all USB based light bulbs, and start plugging those in. Make sure that all the different connections are working as expected and that kind of thing, yeah? So like I say, each one of these USB outputs that are coming off here can handle up to, I believe it was 4 amps. But needless to say, I'll just start plugging them in, like getting it going. So the first socket worked okay, and that lets me know that all my wiring through everything is okay, right? And then let's plug in the second. And it's just, these are good examples because they use a half decent amount of power. They're using about an amp at 5 watts each. So I'll just plug in another. So you can see, got the 3 full bulbs up and running, no problem. Now I just pulled out my Go string, or Gold Zero string of lights, and there are 4 USB lights that I use in my wall tent and in the ice hut and stuff that I showed in the previous video. But you can see they've all lit up as well. And now that's all just driving off this battery. So the thinking really is, like I say, I've got to just turn around and I'll just kind of move this forward a bit. I really just don't like how precarious that these are sitting. I was hoping to originally keep the board together so it sat flat onto this plastic plate, but because of how close the solder point connections were to the next unit over, I was just leery in that regard of keeping them together as a set. So the secondary ramifications of that are, I'm going to have to go get some larger shrink wrap to put around these to stop them from touching each other, and then I'll probably just do that off camera. But needless to say, then you just turn around and kind of press this all flat and close the lid, and it's sealed up and ready to go. So I'll go off and do that, like I say, kind of protecting the circuitry, if you will. And I'll show you the box fully closed and everything when it's all a completed unit, yeah? Alright, well I actually had a change of heart about the shrink wrap and kind of thought about it for a second when I looked at the specs on these units here, yeah? And each one of these units can put out 25 watts. And that starts to generate a half decent amount of power given the nature of, you know, what they're doing. And needless to say, they're going to start throwing heat. So I know I want to kind of protect these from each other and still have them be flexible in the box nut, but I decided I'm going to use a bicycle tube instead. So I'm just going to cut short lengths of this where they can just slide into a sleeve of bicycle tube, and that'll just sit down in. That'll protect, you know, each one from each other and that kind of thing, and give it the ability to still have airflow going across this unit and allow air to heat, escape and that kind of thing. Whereas I think the shrink wrap, because it would have been, confining right onto the circuitry and everything else, that it would have raised up the temperatures to potentially a risky level. So I just thought I'd kind of add that into the video so there was no mysteries to what I was doing, yeah? But, when it comes to a lot of my projects, I like to just kind of improv things on the fly as, I see what fits and works and just kind of move forward with it, right? So needless to say, I'm going to go off, cut 4 lengths of this, put them on here, seal that, and then seal the box. And then I'll flip back over to using the unit as kind of a sealed unit and talk about some of the expectations, yeah? Alright, well you can see the bicycle tube was an easy hack. It allowed it to keep all the different circuits in isolation from each other, and I can still just move these and kind of roll them back and replace bits and stuff or detach things, and I've got the freedom to kind of muck about, if you will. So I'm just going to seal that all up now. As simple as that. And there you have it. We've got our kind of sealed box. There's nothing shaking in there. It's all solid. You know, it's good in that regard. And like I say, we'll kind of look at turning around and just doing the light test and all that stuff again now that the box is all closed. And I'm just kind of walk through things. So yeah, that worked. And these are flipped to each other. So I'll do the third spot. Yeah. Flip the USB, do the fourth. Yeah. See, that one doesn't seem to throw the power. Oh yeah. It's okay. Yeah, it's a little concerning. For this one connection, it seems to not throw quite as much power as the rest. But such is life. I'll have to... I've got a meter coming in the mail. In a couple days, I'll check to exactly why that is. But and then we'll just use the other battery block that I have as a kind of test and say, all right, well, I know that I'm throwing charge in as soon as I plug this in and turn that on. So, and I can see that, yeah, I'm throwing power into the block just because these lights are staying lit, yeah? And I'll turn around and hook back in to see that, yeah, I can see that I'm flowing power out, and I still have that light sitting on. So I'll watch that for a minute, but I'm really under the premise of this is charging at the same time as it's delivering power. And the circuitry should be, they're all in isolation from each other, yeah? Now I'll kind of shift angles here and wrap this video up and talk about some of the kind of finer details I'm expecting to see, you know, in performance out of this as I move forward in time. Like I say, I've got to go back and check the connections on that one. It shouldn't be dim like that. I've probably just got a poor soldered connection or something. But yeah, I'll shift angles here. I'll go back and kind of talk about expectations and performance that I should see out of this as I move through time in the field, yeah? Alright guys, well I just figured I'd jump into the backyard, a bit of sun up. So I've got a 50-watt flexible solar panel here, and they're really lightweight. It's only like 3 pounds, you know, it's fairly easy to kind of tote with me if I'm going out into the field and that kind of thing. And really the core of this setup is going to be, you know, this 50-watt solar panel and this box, yeah? So I'll turn around and kind of show you the maximum capability of this unit with everything kind of working all at one time, and that way you guys can get a bit of bearing to things, if you will. So first order of business, I'm just going to turn around and pull off some of my USB-C cables that I've got here, and I've got my cell phone and my tablet, and the thinking really is we'll just get those plugged in. And like I say, this is charging at 10 amps an hour into that battery, and it's a 100 ampere hour battery. So, you know, 10 hours of sunlight, and from dead to full, this thing will be absolutely kind of topped up, if you will. But let me just, like I say, plug in a few of these cables. I know there's a lot of noise in the background. I live on a fairly main road in the city I'm in, so, but either way, so that's taking a charge now. And I can see that it's, hopefully I'll catch this on the camera. Bear with me. It's taking a fast charge down here. Like I say, I don't know if the light's seeing that very well, but either way, it's fast charging. And then be the same now with my tablet. Plug that in at the same time. That's taking a charge now as well. And let's see if it's lighting up as the fast as well. The cable I'm using might not be. Yeah, so that's taking a fast charge as well. I know it's really bright, so either way. So these are both fast charging at the same time. And then, like I say, turn around and plug in a light. Got my light going. Hopefully the camera's picking that up. And then I've got that string of lights. I'll plug that in as well. I can see those are lighting up. Like I say, hopefully the camera's picking that up. So I've got things picking up off all of these, and I just need to grab one more USB-C cable, and I'll be able to plug this in and charge via USB-C at the same time as I'm taking in from the solar panels, yeah? So just give me 2 seconds, I'll go grab a cable. All right, so like I say, just gonna plug in the USB-C. Now I could go USB-C to USB-C and that kind of thing, but these are just the wires I have at the time. And I can plug that in now at the same time. So I'm taking power in from this battery bank, power in from the solar panels, and I'm still able to run, you know, lights. I'm able to rapid charge my cell phone and my tablet, and I'm running this string of lights all at the same time. And to give you an idea, there's 320 watts worth of power in here. So, you know, if you're running a single, you know, 5-watt light bulb, say, you know, you're going to be able to run that for days and days and days non-stop off this kind of setup before you even have to recharge. You know, I really designed this because I do a lot of heavy draw on the USB power, being you know, when I'm out in the field making these types of videos and that kind of thing of, you know, I'm charging GoPro batteries and I'm wanting to run lights and I'm wanting to keep all my cell phone and, you know, tablet and all that kind of stuff up and running. But hopefully this gives you an idea of, if you want to do kind of large scale, long lasting, you know, USB battery bank kind of technology, you know, this is really a great unit, and these are commercially available. To give you an idea, the kind of size difference of and the technology difference of this unit will output the same amount of power off these devices. Actually, I think this one's just a little bit less than what I'm doing, because I've got kind of top of the line wiring and stuff that's in what we just built. But this still puts out at 5 volts at 3 amps on each output and that kind of thing, yeah? But there's kind of 2 key differences. This one only holds 20,000 milliampere hours worth of power into it, whereas this one holds 100,000. So, you know, this is the equivalent of having 5 of these. And then one of the other key differences really is this uses lithium ion technology when it comes to the batteries, you know, and you can get about 1,000 recharges out of these, and they'll last about 5 to 8 years, that kind of thing, of regular daily use and that kind of stuff, yeah? When it comes to using the lithium iron phosphate batteries, I should be able to get closer to about 4,000 cycles out of this, and I should be able to use it for the next, you know, 10, 15, 20 years kind of thing with regular use. Now, I built this with really deep capacity because I want to have multiple days of being able to run my devices and being able to power things without necessarily having to rely on the solar panel every single day. And that's kind of day of delay, if you will, I call it. And it's the concept of when you're out in the field, if there's a couple days that go by where you've got inclemental weather, you know, it's gray skies, raining and all that kind of stuff, and you're not really taking a lot in off the solar panels, you can still, you know, you cut back on your power demand as much. You know, you're not charging your cell phone and your tablets and those types of things quite as heavy as you normally would, you know, on fair condition days. But you know, I can run this light for, like I say, just under 6 days non-stop, 24 hours a day, before this battery needs to be filled back up again, yeah? So it kind of gives you an idea of the depth and scope of, you know, why I'm running this gear. So, like I said, I could go off into the backcountry and have it where, you know, I get out there and it's just piss weather out for the entire week I'm out there. And then, you know, if I'm conservative and I'm only running light bulbs and, you know, I'm not even running these 24/7, I'm literally just running them in the evening for 5 or 6 hours at a go, that this could potentially last me like, you know, 2-3 weeks before I have to recharge the batteries that are in it. And like I say, with this solar panel, just kind of give you a bit of a closer look at that of, this is light, I'm holding it with one hand, yeah? It weighs, I think, around 3 pounds, so there's not much to it. You know, they don't normally last as long as like the rigid glass solar panels that you can get, and these ones are a little pricier. But really, I have it so that it's lightweight and portable, you know? But I'll start to wrap the video up here. But if you like this type of content, you know, you enjoy this type of thing, please like, share, and subscribe. And if you made it this far in the video, thanks for watching, yeah? Cheers. So yeah, I guess one of the other kind of parting details I forgot to mention is, you know, this thing's waterproof now, right? I can let this sit out in the rain and that kind of stuff. When I'm not plugged in, I just close up all my, you know, connection outputs or inputs, depending on, you know, how I'm going, and all the MC4 connections and all that, they're all waterproof. So I could let this sit out in torrential rains and it'll take a charge, and I won't worry about, you know, any of the internal components getting soaked or any of that business. Of the way that we built this is all designed to be fully waterproof and, you know, rugged and durable for when I'm out in the field. Yeah.